Okay, binomial expansions, lesson 2. This is the work we did in lesson 1. This was our binomial expansion for 1 plus x to the power n. That's the formula given to you in the book. This was our expansion for the example here, 1 minus 2x to the power of a half. Now, one more thing before we move on. You'll see this expansion, the powers of x just keep getting bigger and bigger and bigger. So as a way of approximating to a value, like we did here for the square root of 2, I think I made an arithmetic error here anyway, it's about right. These powers of x just keep getting bigger, x cubed, x to the power 4, x to the power 5. So if x was more than 1, then these numbers are just going to get huge. And as a way of approximating to something, it's useless because your approximations are just going to keep getting bigger and bigger. This only works as a way of approximating to a value if this whole thing here, if the value of x, if this whole thing here is less than 1. So if this whole thing is less than 1, if this is less than 1, if this is less than 1, then you can see if I've got a number less than 1 that I'm cubing, or to the power 4, or to the power 5, then that number is going to get smaller and smaller and smaller, and so we can start to ignore powers of x. So we need to make sure that we know when this works and when it doesn't. And this one here would only work if minus 2x was less than 1. In actual fact, what we mean is that this can be negative, but it's still got to be between minus 1 and 0. In other words, the modulus of minus 2x has to be less than 1. Minus 2x must be somewhere between minus 1 and 1. That way, all our powers of x will increasingly tend towards 0, therefore making my approximation worthwhile. All right, let's look at this one. Here, I'm looking at a negative rather than a fraction that we looked at over here. I'm looking at a negative, but the formula still works. This formula works for negatives and fractions, and indeed both. One thing about this formula though, it's got a 1 here. We haven't got a 1 here, we need to get a 1 here. Now there is a formula in the book, in the formula book, where you've got an a here, and what they're going to do, what they tell you to do is exactly as we're going to do, but I'm not going to use the formula they have. I'm going to use our original formula, but I must have a 1 here. To get a 1 here, I'm going to divide everything in here by 4. So divide everything in our bracket by 4, so this becomes a 1 plus 3 over 8x to the power minus 2. I've taken a 4 out, so I need a minus 2 there. So let's just tidy this up a bit. This becomes 1 over 16, and now I've got an expression here which I can expand using the binomial expansion. And what I need to do is then just multiply my whole answer by a 16th. So let's do that. 1 over 16 times by. So I'm just glancing up at the formula all the time. So I've got a 1 here plus nx, that's minus 2 times 3 over 8. So that would be minus 6 over 8, or minus 3 over 4x. Plus, this is where I need to show my working, minus 2 times minus 2 take 1 times x squared. Well, that's the whole of 3 over 8x squared divided by 2 factorial. This particular expansion I'm going to take up to and including powers of x squared. Okay, so I'm stopping there. You could add another one on if you want. So 1 over 16, and now I'm just doing some numeracy, 3 over 4x. So this is minus 2 times minus 3, which would be 6. This is 9 over 64, so 9 times 6 is 54 over 64 times x squared, all divided by 2 fairly horrible fractions, so we need to tidy that one up. 1 minus 3 over 4x plus 54 over 128x squared. This can clearly be simplified. That looks like 27 over 64. And that's how you do an expansion where this number is not 1. If it's not 1, then take it out. Don't forget to take it out of the bracket with the minus 2. And you should be left with something, an expression here where you've got a 1 here, and then you can start doing the expansion just as we did in the first example.